my dear students. I hope you all are enjoying this series on vector calculus. So in this video we are going to do or learn a very important concept in vector calculus or in geometry, which is the curvature. Okay. So before introducing, I'll just give you a quick recap of what we know. We know that if we have a parameterized curve with parameter t, then we can have an intrinsic parameter which is 0 to t. The curve's equation is xt. Then the intrinsic parameter s is x prime tau modulus d tau from 0 to t integration. And then we saw that there is a unit tangent vector which is denoted by tt, and this is equal to x prime t over mod of x prime t, and this was also equal to x dash s. Okay, so this is what we have done till now, and then we saw the properties of this unit tangent vector. So we see that this unit tangent vector has many properties, and one of them was that modulus of dt by dt at any time gives us the rate of change of, this gives us the angular rate of change of t with respect to small t. Right, now what does that mean? So it means that if you look at this curve, so you have a curve like this. Okay, so if you are standing at this point, this is your unit vector. Okay, if you are standing at this point, this is your unit tangent vector. If you are standing at this point, this is going to be unit tangent vector's direction. So you can see that the unit tangent vector is changing. So what is the angular rate of change of this unit tangent vector with respect to the parameter t? That is denoted by dt by dt. That also makes sense, right? This is how we do something like rate of change. Okay, now we define curvature. So if you literally look at the meaning of curvature, curvature is telling us how much something is changing, right? If we are on a curve, so we are saying the curvature of the curve is changing. So we define curvature of a curve as follows. So definition is the curvature kappa, that is the notation like this, like a k, of a path x in R cube is the angular rate of change of direction of unit tangent vector tt, which is unit tangent vector with respect to the parameter s, or the parameter s is your intrinsic parameter now. Or you can write like this: angular rate of change of the direction of tt, okay, per unit change in distance along the path. So that means if I go from, suppose this is my curve, and if I am standing at this point here, this is my unit tangent vector. I travel 1 unit distance, I reach this point, this is my unit tangent vector. Now I would like to know how much is the change in this direction. Okay, so that angular angles of these two directions. So that gives me the curvature of the curve kappa, right? So this is how we are going to define curvature. So you understand that if I give you these two curves, look at this curve and look at this curve. Can you tell me in which of the following two curves the curvature is more? You can type in the comment box. You let me know in which of the two curves the curvature is more. Look at the left hand side curve. You have something like this. You can see that there is very less change in the direction of the tangent vector. And here you can see I am starting from here, then I am going like this, I am going like this, I am going like this, going like this, going like this, going like this, like this. So there is a huge change in the angular, in the direction of the unit tangent vector. So this curve has low curvature. So this is just physically what curvature is. Curvature is angular rate of change in the direction of this unit tangent vector if I move 1 unit along the curve, distance along the curve. So this curve has high curvature. Right? Now this was the physical interpretation of curvature. Now let us see. So also, do you agree that curvature changes at every point? For example, if I have something like this and then like this, okay, and maybe here is some smooth, maybe we avoid corners. So in this case, here the tangent is not at all changing. So there is no curvature, zero curvature. Okay, but here the curvature is there. So it means that curvature is a function of time, right? So we have at different t parameter, you have different curvatures, right, for a curve. Okay, so this is, we told you that rate of change of angular rate of change of the direction of unit tangent vector with respect to s. Okay, so we are looking for, and also we saw that this quantity dt by dt modulus represents the angular rate of change in direction of tt. This is what we have done in the last video with respect to the parameter time, with respect to the parameter t, right? But I want this with respect to s. So if I look at this quantity dt by dt divided by ds by dt. Okay, so this is chain rule. This gives us dt by ds modulus, which is nothing but the definition of curvature, because definition of curvature says what is the rate of change of the angular rate of change of the direction of t with respect to a unit change in the distance, right? So this is how we are going to define the curvature for any curve, right? So let us do one or two problems. Look at this problem. For the circle xt equal to a cos t comma a sin t, where 0 less than t less than 2 pi, find the curvature. Find the curvature. So now here, you know that for finding the curvature, I have to have my tangent vector, unit tangent vector. So xt here is a cos t comma a sin t. So x prime t is going to be minus a sin t comma a cos t, right? And x prime t modulus is going to be square root of a square sin square t plus a square cos square t. So that is square root of a square, that is a, right? Therefore, unit tangent vector is going to be xt over modulus of xt, which is minus a, x prime t, minus a sin t comma a cos t. I have to divide with an a, so I'll get minus sin t comma cos t. So this is my unit tangent vector, right? Now I have to look at dt by dt. So if I have to look at dt by dt, that is going to be, if you differentiate with respect to time, that is going to be minus cos t comma minus sin t. And in the definition of kappa, we need modulus of this. So dt by dt's modulus is square root of cos square t plus sin square t, which is 1. And then we know that kappa t is dt by dt divided by ds by dt. Now what is s here? So s is here 0 to t modulus of x prime tau d tau. So that is 0 to t x prime tau. X prime we just computed here. X prime tau we just computed a d tau. So you get at. So your s is at. So ds by dt is a. Therefore kappa is, this is 1, this is a. So for a circle of radius a, 1 by a is the curvature. So first of all note that this is constant. 1 by a is constant. Right? So that makes sense also, because if you draw a circle, you can see that everywhere you have to move with the same speed. Okay, so there is nothing like somewhere the curve is changing fast and somewhere it is changing slow. And moreover, the curvature is inversely proportional to the radius. So it means that if you have a high radius, the curvature will be low. So you try making a small circle and you make a large circle. You'll see that for this you have, like, this is hard to draw. It means that there is more curvature, right? So you have to be, you have to change your pencil faster. This is easy to draw because it has low curvature. So you see, if this is a circle of radius say 0.5, then the curvature is 2 here, and this is say radius of circle's radius is say 5, this is 0.2 here. Right, now you can see that here the curvature is high, here the curvature is low. Okay, thank you. I hope you understand everything about curvature. We'll be doing more problems on this subject of curvature. Okay, if you have any comments or any doubts, please write in the comment box. Thank you for watching this video. Please share this video and subscribe to my channel. Happy learning.